Hi everyone, welcome back to this video series on the Comptia Network Plus course. Coaxial cable specifications, RG rating, popular name Ethernet implementation type of cable, RG58U non-applicable non-solid copper, RG58AU thin net 10 base 2 stranded copper, RG58 thick net 10 base 5 solid copper, Rj62 ARCnet non-applicable solid stranded. Although some great advantages are associated with using coax cable, such as the braided shielding that provides a fair resistance to electromagnetic pollution like electromagnetic interference, EMI, and radio frequency interference. All types of stray electronic signals can make their way onto a network cable and cause communications problems. Understanding EMI and RFI is critical to your networking success. Signal bounce. With coaxial cable, the signal travels up and down the entire length of the wire. When the signal reaches the end of the wire, the electrical change from copper to air prevents the conversion from simply falling out the end. Instead, the signal bounces back down the wire it just traversed. This creates an echo just as if you were yelling into a canyon. These additional signals on the wire make communication impossible. To prevent this, you place a terminator on each end of the wire to absorb the unwanted echo. Technically, proper termination also requires that one terminator be connected to a ground. Connecting both terminators to a ground creates a ground loop which can produce all kinds of bizarre ghost-like activity, for example, a network chair that appears and disappears. If you are not sure where to find a good ground point, connect one terminator to a screw holding power supply inside a computer. This ensures that you're using the same ground as the PC. This does assume, however, that the outlet into which the PC is plugged is properly grounded. Twisted pair cable. Twisted pair cable consists of multiple individually insulated wires that are twisted together in pairs. Sometimes a metallic shield is placed around the twisted pairs, hence the name shielded twisted pair (STP). You might see this type of cabling in token ring installations. More commonly, you see the cable without outer shielding. It's called unshielded twisted pair (UTP). UTP is commonly used in 10 base T star wired networks. Let's take a look at why the wires in this type of cable are twisted. When electromagnetic signals are conducted on wires that are in close proximity, such as inside a cable, some electromagnetic interference occurs. In this scenario, the interference is called crosstalk. Twisting two wires together as a pair minimizes such interference and also provides some protection against interference from outside sources. This type of cable is the most common today. It is popular for several reasons. It's cheaper than other types of cabling. It's easy to work with. It permits transmission rates considered impossible 10 years ago. UTP cable is rated for the following categories. Category 1, 2 twisted pair, 4 wires, voice grade, not rated for data communications. Oldest UTP, frequently referred to as POTS or plain old telephone service before 1983. This was the standard cable used throughout the North American telephone system POTS cable still exists in parts of the public switched telephone network PSTN. Category 2, 4 twisted pair wires, 4 twisted pair 8 wires suitable for up to 4 megabits per second. Category 3, 4 twisted pair 8 wires with 3 twists per foot, acceptable for 10 megabits per second, a popular cable choice since the mid-80s. Category 4, a twisted pair 8 wires and rated for 16 megabits per second. Category 5, 4 twisted pair and rated for 100 megabits per second. Category 6, 4 twisted pair 8 wires and rated for 1000 megabits per second. Frequently you will hear category shortened to CAT. Today any cable that you install should be a minimum of Cat5. This is a minimum because some cable is now certified to carry a bandwidth signal of 350 MHz or beyond. This allows unshielded twisted pair cables to reach a speed of 1 gigabits per second, which is fast enough to carry broadcast quality video over network. A common saying is that there are 3 ways to do things: the right way, the wrong way, and the IBM way. IBM way uses types instead of categories when referring to TP twisted pair cabling specifications, even though a cabling type may seem to correspond to a cabling category, such as type 1 and category 1. The two are not the same. IBM defines its own specifications. Connecting UTP. Clearly, a BNC connector won't fit easily on UTP cables, so you need to use a registered jack connector. You are probably familiar with RJ connectors. Most telephones connect with an Rj11 connector. The connector used with UTP cable is called Rj45. Rj11 has 4 wires or 2 pairs, and the network connector RJ45 has 4 pairs or 8 wires. So here's a picture of a Cat1 cable with an RJ11 head. This is used for the old telephone system PSTN. And here we have a category 5 Ethernet cable with an RJ45 head. In almost every case, UTP uses RJ connectors. Even now the extinct ARCnet used RJ connectors. You use a crimper to attach an RJ connector to a cable, just as you use a crimper with a BNC connector. The only difference is that the die that holds the connector is a different shape. Higher quality crimping tools have interchangeable dies for both types of cables. Signaling methods. The amount of cables available bandwidth overall capacity such as 10 megabits per second that is used by each signal depends on whether the signaling method is baseband or broadband. Baseband uses the entire bandwidth of the cable for each signal using one channel. It is typically used with digital signaling. In broadband, multiple signals can be transmitted on the same cable simultaneously by means of frequency division multiplexing (FDM). Multiplexing is dividing a single medium into multiple channels. With FDM, a cable's bandwidth is divided into separate channels or frequencies, and multiple signals can traverse the cable on these frequencies simultaneously. FDM is typically used for analog transmissions. Another method, time division multiplexing (TDM), can also be used to further divide each individual FDM frequency into individual time slots. Additionally, TDM can be used on baseband systems. Ethernet cable descriptions. Ethernet cable types are described using a code that follows this format. End signal X. Generally speaking, N is the signaling rate in megabits per second, and signal is the signaling rate, which is either base or broad, baseband or broadband. X is a unique identifier for that specific Ethernet cabling scheme. Let's use a generic example. 10 base X. The two-digit number 10 indicates that the transmission speed is 10 meg or 10 megabits. The value X can have different meanings. For example, 5 in 10 base 5 indicates that the maximum distance that the signal can travel 500 meters. Good. The 2 in 10 base 2 is used the same way but fudges the truth. The real limitation is 185 meters. Only the IEEE committee knows for sure what this is about. We can only guess that it's because 10 base 2 seems easier to say than 10 base 1.85. Another 10 base standard is 10 base T. T is short for twisted pair. This is the standard for running 10 megabit Ethernet over two pairs of category 3, 4 or 5 UTP. The fourth and currently final 10 base is 10 base F. The F is short for fiber. 10 base F is the standard for running 10 megabit Ethernet over fiber optic cable. 100 base T. As network applications increased in complexity, so did their bandwidth requirements. 10 megabit technologies were too slow. Businesses were clamoring for a higher speed standard so that their data could be transmitted at an acceptable rate of speed. A 100 megabit standard was needed. Thus, the 100 base T standard was developed. The 100 base T standard is a general category of standards for Ethernet transmissions at a data rate of 100 megabits per second. This Ethernet standard is also known as Fast Ethernet. There are two major standards for 100 base T. 100 base TX, the implementation of 100 base T that is simply a faster version of 10 base T. It uses two UTP pairs, four wires in a category 5 UTP cable or type 1 shielded twisted pair. 100 base T4, the implementation of 100 base T that runs over 4 pairs 8 wires of category 3, 4 or 5 UTP cable. 100 base VG. This 100 megabit Ethernet replacement came from HP, and in the popularity race it lost. Even the name wasn't settled upon, so you may find it referred to as VG LAN, VG ANILAN or ANILAN. Although it used UTP cable, it didn't follow the popular Ethernet standard. Ugh, God. It attempted to improve on Ethernet by using collision avoidance as a method for controlling network traffic. The point here is that the 100 base VG standard was not compatible with 10 base X and Ethernet. The combination of its incompatibility and its actually less than 100 megabits throughput due to its access method, which is discussed elsewhere in this book, ultimately spelled its demise. However, it was basically 100 megabits and it was out the door early in the game because some companies implemented this standard. You also know about it, fiber optic cable. Um, because fiber optic cable transmits digital signals using light pulses rather than electricity, it is immune to EMI and RFI. But you should know at this point that both could affect network performance. Anyone who has seen UTP cable for a network run down elevator shaft would without doubt appreciate this feature of fiber. Light is carried on either a glass or a plastic core. Glass can carry the signal a greater distance, but plastic costs less. Regardless of which core is used, there is a shield wrapped around it and it is surrounded by cladding, which is more glass than refracts the light back into the core. This is often wrapped in an armor cladding, typically Kevlar, and then sheeted in PVC or plenum. Fiber optic cables can use a myriad of different connectors, but the two most popular and recognizable are straight tip STP or subscriber connector SC connectors. The ST fiber optic connector developed by AT&T is probably the most widely used fiber optic connector. It uses a BNC attachment mechanism similar to the thin-net connection mechanism, which makes connections and disconnections fairly easy. It's easy Its ease of use is one of the attributes that makes this connector so popular. So this is a fiber optic connector. The SC connector, sometimes also known as the square connector, is another type of fiber optic connector. SC connectors are latched connectors. This makes it possible for the connector to be pulled out without releasing the connector's hatch, usually by pressing the release button. So this is a picture of the SC connector. SC connectors work with either single mode or multi-mode optical fibers, and they will last for around 1,000 matings. They are seeing increased use but aren't as popular as ST's connectors for LAN connections. If data runs are measured in kilometers, fiber optic is your cable of choice because copper cannot reach more than 500 meters, about 15,000 feet, without electronics regenerating the signal. You may also want to opt for fiber optic cable if an installation requires high security because it does not create a readable magnetic field. Although fiber optic technology was initially very expensive and difficult to work with, it is now being used in some interesting places such as gigabit Ethernet backbones. Also, some companies plan to bring fiber optic speeds to the desktop Ethernet running at 10 megabits per second over fiber optic cable is normally designated 10 base F. The 100 megabits version of this implementation is 100 base FX. Although fiber optic cable may sound like the solution to many problems, it has pros and cons. Just as other cable types on the pro side, fiber optic cable is completely immune to EMI and RFI. can transmit up to 4 kilometers, about 2 miles. On the con side, it is difficult to install, requires a bigger investment and installation and materials. So I'm going to leave it here today for this video. If you liked, please consider like, sharing and subscribing, and thanks for listening.